Hey guys, today we are going to do some algebra review. We will solve some different types of equations. We will do some simplifying of terms with division, some with radicals, and we'll do some factoring. So here we go. Circle each term. So it's important to understand what a term actually is. 4n is a term. -7 is a term. -3x squared m is a term, and then all of this is one term. Terms are separated by addition and subtraction, and even though inside these parentheses there are 3 separate terms, they all need to be multiplied by this 15 first before they become 3 separate terms. Okay, so this 5 times these parentheses represents one term. So here's one term. Here's a term, and then here's a term, so there's 3 there. Okay, so some equations, and we'll start pretty basic and work our way up from there. So we move this 3 over, and we get 4x equals 8. Okay, by subtracting 3 and then divide by 4, so x is 2. Okay, we subtract this 7. 25 minus 7 is 18, so we get -3x equals 18. And divide by -3, so x is -6. Number 5, we should subtract this 11, so we get -3 times 2x plus 7 equals 5. From there, we can either divide by -3 and then solve from there, or we can distribute the -3 and solve from there. I think with this one, distributing is going to be the easier way to go so that we don't have fractions until later. So we'll distribute that -3. -6x minus 21 equals 5. Add 21 and we get -6x equals 26. And then we can divide by -6. So x is 26 over -6. So x is negative. And 2 goes into 26 and 6, 13 times and 3 times. Okay, so here we are solving, and it says up here solve for x, so that just means get x by itself. So we're going to subtract or add all these other terms. So we get 5xc equals, okay, so then on the right side we've got 8 plus 4, that's 12. Then we have a -3n. and a positive 7p. Then we divide both sides by 5 and c to get x by itself. So x is 12 minus 3n plus 7p over 5c. Now we have variables on both sides here. So we want those on the same side. So we'll move this 12x over to the left side, and in the same step, let's move this -7 over. So we have 15x minus 12x, that's 3x, and 9 plus 7 is 16. So x is 16/3. On number 8, it looks like we should distribute first, so we have 20x minus 15 plus 10x. Equals 24x minus 3. Then we have some like terms here, 20x and 10x, and we can subtract that 24x. So 20 plus 10 is 30, minus the 24x is 6x, and we can add that 15 to both sides, and -3 plus 15 is 12. And divide by 6, and we get x is 2. Here we should move this 10 to the other side. and we get 4 minus 2x squared equals 16. Okay, now let's square this binomial. When we square a binomial, we get, so we have a plus b squared. We get a squared plus 2ab plus b squared. So that's the first term squared. That's 16. And then 2 times a times b. 2 times 4 times negative 2. So when I multiply these, I get negative 8x. Double that, and I get negative 16x. And then this second term squared is 4x squared. Okay, now from there, let's get everything on one side. So when I subtract 16 from both sides, those actually just cancel. Okay, so I want to put this one in descending order though. So 4x squared is going to go first, minus 16x equals 0. And now I can factor this. So from both terms, I can factor a 4x. When I divide 4x squared by 4x, I have x. And negative 16x divided by 4x is negative 4. And from there, I can get my two solutions. So when I multiply two factors and the product is 0, that means one or both of these factors is going to have to equal 0. So the solutions are any values of x that make a factor equal 0. So 4 times 0 is 0. So I could say x would be 0. And then 4 minus 4 is 0. So the other solution is 4. So my two solutions are 0 and 4. Number 10, when I solve a radical equation, if there's only one radical, I want only that radical on this side by itself. So I will move this 4 to the other side. 10 minus 4 is 6. And now I can square both sides to cancel out that radical. So I get 36 equals 3 minus 2x. And then I'll move this 3 over. 36 minus 3 is 33, equals negative 2x. And then divide, and I get x is negative 33 over 2. Now before I can claim this as my solution, I must plug in my solution here and make sure it's not an extraneous solution. So that's 10 equals the square root of 3 minus 2 times negative 33 over 2 plus 4. So to simplify this, negative times negative is positive, so it's the square root of 3 plus, and then this is 2 over 1, and I can cancel these 2's, and I get 33. So that is the square root of 36 plus 4. Square root of 36 is 6. And 6 plus 4 is 10. So I have 10 equals 10. My solution checks out, so I can keep this solution. If this did not come out to 10 equals 10, then I would have to say this is an extraneous solution and there is no real solution. Number 11. I can start by dividing both sides by 2, and I get tangent x plus 30 equals 3. Okay, now x plus 30 is the angle, which means that the angle is a variable. And the way that I can get rid of tangent, I can cancel out tangent by doing the inverse of tangent, which is arctangent. If I do that to both sides, then tangent goes away here, and I have x plus 30 equals arctangent, or inverse tangent, 3. Now I can move this 30, I can subtract 30 from both sides. So x equals arctangent 3 minus 30. So arctangent 3 minus 30, and I get 41.57 degrees. Or I could have this in radians. So if I was in radians, I would get negative 28.75 radians. So whether it's degrees or radians, it's going to be the same spot on the unit circle. So those are my two possible solutions. Okay, so on number 12, I'll subtract that 5. So I get negative 4 cosine x plus 10 equals 8 minus 5 is 3. And then I will divide by negative 4, so I get cosine x plus 10 equals negative 3/4. And the way I can cancel out cosine is by doing an inverse cosine. So x plus 10 equals inverse or arc cosine, negative 3/4. And then I can cancel out this 10 by doing minus 10. So second cosine, negative 3/4 minus 10. And I get negative 7.58, and that is in radians. Or, if I did it in degrees, I would have 128.59 degrees. Okay, next we are going to do some simplifying of expressions. So when I'm dividing two fractions, the way I like to divide fractions is make this outer loop here and multiply these, and that will be my numerator. So it's AD. And this inner loop here, I multiply these, and that's the denominator, BC. Okay, so now right here in the middle of the equal sign, that's where the division line is. So I have A over B equals C, or over C, which is C over 1. So I get 1 times A over B times C. And then this time the division is right here. So I get A times C, and then this is A over 1 on top, so it's 1 times B, and that is my numerator, or my denominator. So it's AC over B. Number 16. I'm going to put everything in terms of sine or cosine. So I have cosine x, and I'm just going to write that as cosine x over 1 over, and then secant is the reciprocal of cosine, which is 1 over cosine x. So when I do my outer loop here, I get cosine x times cosine x, and the way that's written is cosine squared x. And the denominator 1 times 1 is 1, so cosine squared x is my output here. Now be careful to make sure it's cosine squared x, not cosine x squared. Those are different. Cotangent is the reciprocal of tangent. Tangent is sine over cosine. Cotangent is cosine over sine. So cosine x over sine x over cosine x, which is cosine x over 1. So my outer loop is cosine x. My inner loop is sine x, cosine x, and cosine x will cancel, so I have 1 over sine x. Okay, 1 over sine x, though, can be simplified. That is cosecant x. It's easiest when I start to put things in terms of sine and cosine, but when I finish, I want it in the simplest version possible. 1 over sine is in terms of sine or cosine, but cosecant x is a simpler form. When I'm dealing with numbers like this with radicals, I can multiply the numbers outside the radicals and get 15. And I can multiply the numbers inside the radicals and get the square root of 16. The square root of 16 is 4, so it's 15 times 4, which is 60. When I'm adding, I can't do anything unless the radicals are the same. Okay, but I can simplify this square root of 8. So the square root of 8 is the same as the square root of 4 times 2, and the square root of 4 is 2, so the square root of 8 is 2 times the square root of 2. So I have 5 root 2 plus 3 times the square root of 8, which is 3 times 2 root 2, and that is 6 root 2. And now I can add these because they have the same numbers here under the radical, and I get 11 times the square root of 2. If I have cosine and then in parentheses 7/11, what does 7/11 represent? It represents an angle measure. But when I do the inverse cosine or arc cosine, 7/11. 7/11 doesn't represent an angle anymore. When it's the inverse, inside these parentheses is a ratio of sides. And in this case, because it's cosine, it happens to be adjacent over hypotenuse. And in our last section here, we are going to factor. Okay, so here I've got 2 terms, and each term has a 3 and an x I can factor out. That is factoring out the greatest common factor. So I can factor out a 3 and an x, and when I divide this first term by 3x, I'm left with x, and when I divide the second term by 3x, I am left with -5. So there is my factored form. Here, the greatest common factor is x. I can factor out an x, and I'm left with 3x plus 19. So there's the factored form. When I have a trinomial with a lead coefficient of 1, if it is factorable, there will be a pair of numbers that will multiply to -35 and add to 2. So they'll multiply to c and add to b. And there is a pair of numbers that does that. It's -5 and 7. So x minus 5 times x plus 7. -5 plus 7 is 2. -5 times 7 is -35. Here it looks like all I can factor is a GCF again. So I can factor out an x squared out of both terms. And that leaves me with 8x to the 5th plus 1. So when I factor everything out of a term, I'm dividing it by itself. That leaves me with 1. Okay, so here I have a secant squared x in both terms. So here's a term and here's a term, and they both have a secant squared x. So I can factor out secant squared x from both terms, and that leaves me with sine squared x minus 1. Okay, so I've divided secant squared x out of this term. I get sine squared x. Divide secant squared x out of this term, and I get -1. Now there's a little more I can do with this one, though, because I see inside the parentheses a difference of squares. Difference because it's subtraction. Squares because this is a square number. I know that because it's got a squared on it. And this one is a square number because 1 is the same as 1 squared. So secant squared x stays right where it is, and this difference of squares gets split into a binomial and into two binomials, and those binomials are the square roots of these terms, one with a plus, one with a minus. So it's sine x plus 1 times sine x minus 1. Okay, so here, once again, I can factor out a greatest common factor out of these two terms. I can factor out a tangent squared x, so I get tangent squared x times 1 plus cosecant squared x. Now this one is a sum of squares, and a sum of squares we're not going to be able to factor. Number 28. Anytime I'm factoring, it's a really good idea to look for a GCF first. And here I have a GCF of 2 that I can factor out, and that leaves me with x to the 4th plus 9x squared minus 10. Okay, now I've got 4th and squared instead of squared and first power. That just means that if I'm able to factor this, instead of x's here, I'll have x squared. Now, is there a pair of numbers that will multiply to negative 10 and add up to 9? And the answer is yes. Those numbers are 10 and negative 1. So positive 10 and negative 1. Now I can actually go a little bit further with this one because here I see another difference of squares. So I have 2 and then x squared plus 10, and this difference of squares will get split into two binomials, one with a plus, one with a minus. The square root of x squared is x. The square root of 1 is 1, so x squared minus 1 is x plus 1 times x minus 1. And then on number 29, it looks like there is not a GCF to factor out, so let's factor this one by grouping. So first, let's multiply A and C. 15 times 6. 15 times 6 is 90. So I need two numbers that multiply to 90 and add to 19. And I believe those two numbers are going to be 10 and 9. 10 times 9 is 90. 10 plus 9 is 19. So I'm going to split this 19x into 10x plus 9x. So I have 15x squared plus 10x plus 9x plus 6. So all I've done was split this 19 into a 10 plus 9. Now that I've done that, I can factor by grouping. So from this first group, I can factor out a 5x. And that leaves me with 3x plus 2. From this second group, I can factor out a positive 3. And that leaves me with 3x plus 2. And now I can basically factor out the GCF out of these two terms, and I get 3x plus 2, and then I'm left with 5x plus 3. And there is my factored form.